Welcome to Module 8 of the Documentation of Contract Quantities class. We are in the Documentation Guide, Section A, reviewing our general requirements, and in this module we will present maximum payment, yield checks, and depth checks. Maximum payment. Maximum payment is based on weight items, either paid by the pound, ton, or gallon when it's calculated from weight tickets. You can follow along on page A15 in the doc guide. Maximum payment is an incentive for the contractor to bring us 100% of the theoretical quantity that we believe we need. It is there to account for differences in density of compacted materials, irregular surfaces, in order to fill a volume with a certain amount of tonnage or pounds. It is based on the planned quantity or the quantity specified by the engineer. What is the quantity specified by the engineer? If we make some field measurements and that quantity is different than the designer's planned quantity, then we shall use the specified by the engineer quantity. It is our most accurate theoretical quantity right now. The method of measurement for each pay item in the spec book gives the maximum payment percentage. However, on page A15, we have grouped them together so it is a convenient lookup tool. Here's a snapshot of the top half of page A15 in the doc guide. Maximum payment. Examples are on F34 and F35. Here we can see items with maximum payment. We have fertilizers, we have aggregate materials. Here's some HMA. This would be the center column would be their pay units, and then the final column would be that maximum payment amount. But what does it mean when I have a maximum payment? Let's take a look at an example. Workbook page 2. We have a maximum payment example in tons. We have aggregate base course type B. We had a planned quantity of 7,783 tons. We have a revised planned quantity of 7,850 tons. So we've taken some measurements, made some calculations that brought us a more accurate number than what the designer gave us for the purpose of bidding. To calculate our maximum payment, we take our most accurate theoretical quantity, our 7,850 tons, times the max pay percentage for that item. If we were to look on page A15 for aggregate base course type B, we would see the maximum payment is 108%. Expressed as a decimal, that'd be 1.08 times our most accurate theoretical quantity gives us a maximum amount we can pay for of 8,478 tons. The contractor delivered by weight tickets 8,496 tons. What would be the final payment to the contractor? Give you a minute. The final pay quantity would be 8,478 tons. When we're evaluating max pay, we're looking at our max pay number versus what was delivered, and we always pay the smaller amount. I cannot pay more than the max, so if the contractor brings me more than maximum, that's my cap by maximum payment. Well, what happens if the contractor brings me less than max pay? Let's look at a case where the contractor delivered less than max pay. In this case, the contractor brought us 8,450 tons. Our maximum payment's 8,478. What would the final payment be? That's correct. We pay the smaller amount. The final payment would be 8,450, what they brought me. I cannot pay more than the maximum, but I don't want to pay them for more than they actually brought me. So once again, in evaluating max pay, we're going to use our most accurate planned quantity or theoretical quantity. We're going to find the maximum payment amount in our table or in our spec article. We're going to compute max payment, and we're going to assess that against the amount that the contractor delivered, and we will always pay the smaller number between max pay and what they delivered. Another key factor in maximum payment is this evaluation is only performed at the end of the pay item. When we are completely done placing this aggregate base course type B, I would evaluate this max pay, and my final pay estimate amount would be based off of my max pay determination. Do not assess max pay on a daily basis. That's not the intention, and we want everybody to do it in a standard fashion to evaluate at the end of your pay item. Our next topic is yield checks. Yield checks help us determine if we are getting a thickness or a volume that we require based on theoretical calculations. Yield checks are recommended for all materials. However, they are absolutely required for two items: hot mix asphalt paving and Portland cement concrete paving. For hot mix asphalt paving, yield checks are required frequently during each day of paving and an overall yield check at the end of the day. For concrete paving, at the end of each day is the only requirement by spec. Why do we want to be frequently during hot mix asphalt paving? Well, our yield check is telling us how thick the mat is. We can measure width pretty accurately. We can measure length pretty accurately. But there's no real good way to measure the thickness of an HMA mat other than cutting a core. On workbook page 43, we show the typical HMA weight or density. Limestone and dolomite aggregate hot mix asphalt typically weighs on the order of 112 pounds per square yard per inch of thickness. Note that surface mixes can weigh more or less depending on the type of aggregate used for the friction, and we will cover surface mixes in a later module. To visualize this, we have 1 square yard, or 36 inches by 36 inches by 1 inches thick. This slab of HMA would weigh approximately 112 pounds. On workbook page 3, we have our generic yield equation, which is the delivered amount divided by the theoretical. We have to calculate our theoretical. This is the amount we think we need based on our dimensions and our estimate of the density. For HMA yield checks on binder course, note this is underlined. This is for binder course materials. Again, we will cover surface mixes in a later module. The equation for the theoretical tons of HMA binder that would be required are width in the units of feet times length in the units of feet times our density, and if you're not told otherwise, we're going to use 112 pounds per square yard inch, times the mat thickness in inches. We have some conversions to get from square feet, square yards, and pounds and tons. We have 9 square feet per square yard times 2,000 pounds per ton. If we cancel all of our units out, the only one left will be tons. It is very important when you plug in your thickness, your length, or your width to use the units that are in this equation. Do not change the units or this equation won't work with these conversion factors. As I said before, if we're not told otherwise, you should use 112 pounds per square yard per inch of thickness for HMA binder course materials. Sometimes the designer will indicate on the plan sheets a different density that they have assumed for calculation purposes. When in doubt, verify with your district materials office. On workbook page 4, we have an example calculation. The numbers that we've plugged in, you will see next on a field book entry. We had a 12-foot paving lane, 7,860 feet long. We're using 112 pounds per square yard inch. We have an 1.5 inch thick mat. So we have our conversions down here, 9 and 2,000. We calculate a theoretical tonnage of 880.3 tons. Our yield equation is delivered over theoretical. I added up my weight tickets for the day. I had 897.9 tons. I used my theoretical amount I calculated, and I divide by that. Times 100 gives me a yield check of 102%. Is that a good yield? Are we satisfied with this day? Yes. In your yield, the minimum we want to see on our yield is 100%. That means we got 100% of what we thought we needed. On page F14 in the doc guide, you can see an example field book entry. We have seen this one before, but now we're going to key in on this page where we have our yield checks right down here. We stated that HMA paving, we require yield checks frequently. Number 1 and number 2 are two different methods of calculating yield checks. In the first one, we looked at the typical tons in a truck, or 12 tons per truck. We plugged that in and we computed the length or the distance we would go. This calculation told us we should see each truck pull up to the paver and go for about 107 feet, or roughly one station. Number 2 tells me how many tons per station. I guess that would be a good one if you're placing a very thick mat and maybe you need several trucks per station. Here we plugged in our lane width, our station of 100 feet, and we then calculated tons. Just good markers so that we can keep an eyeball on our yields as we're doing all of our other inspections on the paving train. Finally, number 3, we have our total yield check. We have our total length, 7,860 feet. The required thickness gives us our theoretical. You saw that on the workbook page previously. And here's our yield calculation for the overall day, where we added up all of our tickets. We show our theoretical and we get 102%. Yield checks can be challenging when we're in urban areas and you have intersections. Here we have some nice little radiuses. We've got these little wedge going on. What about this little water valve? Would I deduct for that area from the area of paving and my calculation? No, this is in the roadway and it looks like it's less than 9 square feet, so I would not deduct for this area. But we have challenges in mat thicknesses, especially when you have an intersection and we have crown in the road for drainage. You can see maybe this section of pavement looks quite a bit thinner than this one over here. So we have variation in the mat thickness as we go along. This might be one where if I'm doing a yield check in this area, I might calculate a theoretical before I get out there in the field. This is going to take a little bit of math. Here's some other paving pictures. What are these guys doing? That's right, we're measuring the width, but I hope this guy puts his tape down so we can measure on the level, right? Horizontal for our transverse widths of pavements, right? It's a nice shot of a paving train. Challenging. Talk about challenging. Yes, here we go. We got almost a 45-degree bank. This is Daytona Speedway. Here's my delivery truck with its HMA in there. We're dumping into the hopper of this material transfer device. Here's the arm of the material transfer device, which is held up by a crane, dumping into this paver that's on this 45-degree bank. Look at these guys. They're leaning quite hard just to stay on the pavement. And who is holding up this paver? We've got a dozer on the top. Everybody always asks, where are the rollers? Well, there you go. Here's our roller. It's held up by a dozer. It's got a water tank to replenish the roller. And here we have our cable system that's holding up these rollers. You know who I don't want to be? One of these guys on the other end of this paver. You know, if that paver slides, it's not going to be a happy day. Anybody here into materials testing? Here we got our nuke test going on for density. I'm not so sure about the radiation safety officer and having the foot right up there on the nuke, but we have challenges and we have to overcome. Thickness determination schedule. It's a pretty fancy word for what? Depth checks, right? We have thickness requirements for our materials when we need to be taking these depth checks, and we need to write them down, because if we don't write them down, we didn't do them. All right, so we got to document our depth checks. Several different ways to obtain depth checks: before and after readings with elevations. Could use a string line. Could use a direct probe in some materials. And at last but not least, we could take cores, especially if we forget to take depth checks. On page A16 through 19 in the doc guide is a section that describes the requirements for documentation of depth checks, or thickness determination schedule. I want to pull your eyes to this bold statement in the middle. It says, blanket statements such as all sidewalk was 4 inches or deeper and all patches were 9 inches are not acceptable. We need actual measurements to be recorded, individual readings at locations. Looking at page A17, This is the top of page A17 right here, and we have our thickness determination schedule. In this column we have the type of construction. We also provide a spec reference, and in the middle is our minimum frequency to document depth checks. Here in this column we tell you what document they can be recorded in. I should say that field books and IDRs are the most common, but with the prolific use of electronic documents and the implementation of CMMS, you may be taking these and documenting them in spreadsheets as well. Method of measurement tells us how we can obtain these depth checks with these footnotes, and they're at the end of the table. You can see all the explanation for these footnotes. Let's take a look at workbook page 5. This would be a good time to pause the video and get your workbook out, or flip to your PDF copy of the workbook and check out this problem. How many depth checks are required for PCC sidewalk that measures 1,000 feet in length by 4 feet wide? On page A18, we can see in our table of thickness determinations for PCC sidewalk, the minimum frequency is 1 for every 1,000 square feet. So I know we're 4 feet wide times 1,000 feet long gives me 4,000 square feet. Divided by the frequency of every 1,000 square feet, I must record at least 4 depth checks. I have to document 4 depth checks for this portion of work. You can see this answer on page 27 in the workbook. On page F36 is an IDR showing a portion of sidewalk. Here we've got PC concrete sidewalk. What does it mean when my pay item ends in a number? This one ends in 4. What does that tell me about this sidewalk? Yes, it must be 4 inches thick. So I got to have some depth checks. Here we go. We've recorded some depth checks right here. I have 5 foot wide sidewalk by 500 feet long. So my area is 2,500 square feet. There's my payment, right? My quantity in units for payment. But it also tells me I have 2,500 square feet of sidewalk. So how many depth checks should I record? The minimum frequency we saw just a moment ago in the workbook was every 1,000 square feet. So I need 2,500 divided by 1,000 equals 2.5. So I need to record at least 3 depth checks. Here we had an overachiever. We got 6 depth checks. We have some stations, some actual readings, right? Looking pretty good. What about this one at 5 inches? Do I owe the contractor some extra money because it's an inch thick? No. The minimum's 4. Thank you for the extra inch, but I'm not going to pay you any more. What if this last depth check had been 3 inches and I didn't get my full 4? Do I document it and just move on? No, that's not it either. We're not observers, we are inspectors. We're ensuring the work is built according to spec. This spec said 4 inches thick. I would tell the contractor, hey, you're a little light. We need to go core out some more. It needs to get a little deeper there in the area of section or of station 5. On page A20, we have also related to sidewalks, cross slope determinations. Cross slopes are transverse to the direction of travel, and they are for American Disabilities Act requirements, or ADA. Again, we have that bold statement in the middle. You cannot use blanket statements. You must record at least the minimum number of actual cross slope checks. Here, underlined at the bottom, cross slope checks have the same frequency as depth checks for our sidewalks. 1 for every 1,000 square feet. Good practice, every time you take a depth check, you should go back and take a cross slope check at the same location once that sidewalk's been placed. Here's our IDR for sidewalk, page F36 in the doc guide. And this time we're looking on this side of the IDR for our cross slope checks. You can see they did a cross slope check at each location. They did a depth check. Yes, we only needed 3, but it's okay to have more. Our criteria on this one looked like it was a maximum of 2%. That is not an absolute. You need to check your special provisions and plans for the designer's requirement for cross slopes, maximum cross slopes each time you're out on your project.